My name is Tilafia and we are excited to present our final project submission for the course Data Science Programming. Before we dive into the details, let me introduce our team information. We are in Group 4 and we are three dedicated team members, Rami, Prasida and Sindhu. For our project, we selected the bank marketing data, which is related to direct marketing campaign conducted by a Portuguese banking institution. These campaigns were carried out via phone calls, often requiring multiple contacts with the same client to determine whether they will subscribe to a term deposit product. Here are some details about the dataset. This dataset is collected between May 2008 to November 2010. The origin of the dataset is from UCI Machine Learning Repository. File type of this dataset is CSV. Size is 3.7 megabyte. This dataset falls under the category of classification, and yes, this dataset has the missing values. These are the dataset variables. Now, why we choose this dataset? Because it represents a real-world classification problem focused on marketing campaigns. The dataset features diverse variables, making it ideal for tasks such as pre-processing, analysis, and modeling. The inclusion of missing values and a mix of categorical and numeric data types offers valuable opportunity for data wrangling and exploration. Being publicly available and widely used, it serves as a standard benchmark in machine learning and data science studies. Now, our team has contributed the work as the following, that is data importing and pre-processing, which includes data cleaning, handling missing values and preparing the dataset for analysis. Prasida contributed by performing data analysis and visualization, uncovering key insights through exploratory data analysis and visualization. Sindhu took charge of data analytics, building predictive models, evaluating their performance, and providing actionable recommendations. Together, we work systematically to address the problem statement and achieve the project objectives. Now, let's move towards our part 1, that is data importing and pre-processing. Before starting with the part 1, let's understand our problem statement of our project. The goal of our project is to predict whether a customer will say yes or no to subscribing to a term deposit offered by a Portuguese bank. This is a binary classification problem where we aim to classify the customer's response. The dataset includes information about the customer such as who they are, how they were contacted, previous interactions, financial details, etc. The challenge is to analyze this data, clean it, and find patterns that can help predict whether a customer will subscribe. We will use techniques like data cleaning, EDA, creating useful features, and building models to identify the most important factors influencing a customer decision. The ultimate aim is to create a reliable prediction model that can help the bank focus on the right customers, making their marketing efforts more effective and more cost efficient. My task, that is data importing and pre-processing. In this section, first we need to import all the essential Python libraries required for our analysis. Let's go through each of them. First is importing pandas. Pandas is a powerful library for handling and analyzing data in a tabular format. It allows us to load the data, clean it and perform EDA using data frames is matplotlib. Matplotlib is a library for creating visualizations. Especially the pyplot module helps us to plot line graphs, scatter plot, and histogram. Third is importing Seaborn. Seaborn is built on top of matplotlib and specializes in creating statistical visualization. It provides high-level commands for generating graphics such as heat map and box plot. Fourth is label encoder. Label encoder converts categorical data like text label into numeric label. For example, a column with labels like yes or no can be converted to 1 and 0. Next is state from Skype. Skype provides advanced tools for scientific computation. The states module includes functions of statistical analysis such as performing t-test or z-scope. This is crucial for understanding the statistical significance of our data. And the last is suppressing warning. It is used to improve clarity while working in Jupyter Notebook. And the purpose for this library is when we are experimenting with code, warning message can clutter the output and make it hard to read. Therefore, we use this library. Now here we can see that our libraries are successfully imported. Once the libraries are successfully imported, let's move on the next part, that is dataset import. I have used pandas for importing the dataset. pd.read csv. This function is used to load csv file into the pandas data frame, and df.head is used to show the first 5 rows of the dataset. It helps us quickly verify if the file was loaded correctly or not. Here we can see that our file is correctly uploaded. Now let's explore the structure and characteristics of our dataset. This step is crucial to understand the dimensions, data types and key statistics, which will guide our pre-processing and analysis. First is shape. Shape attribute provides the number of rows and the columns in the dataset. Here we can see that 45,211 are rows and 17 are the columns. Index provides detailed information about the dataset. It includes column name, data types, and non-null counts for each column, which helps us spot any missing values. Here we can see the column name, non-null count, and data type. Now, describe function gives summary statistics for all columns. For numerical columns, it provides values like mean, median, minimum, maximum, and standard deviation. For categorical columns, it provides count, unique categories, top categories, and frequency. Let's see that. Here we can see that we get the summary of our data set. Now let's move towards the handling of missing data. First, we need to identify is there any missing value in our dataset or not. So we have to run this cell. Here we can see that age, default and contact column having the missing values. So what we can do that we need to fill missing values, or or else we can drop that missing values. But first we have to see which method is more appropriate for our data set. So here I had used mean and median for the age column to see which is more efficient for our data set. So by plotting this graph, here I can get to know that mean is higher than the median. Let's see the graph. Here we can see that mean has the higher value than the median and the presence of outliers seems likely based on the difference between the mean and the median. Now what we can do that outliers can distort the mean. Imputing with the median will be more robust and better represent the majority of the data. Therefore, we are choosing median for filling our missing data for the age column. The default column, we are using value underscore count function to check the categorical values. Here we can get to know that in this default column we have yes and no category dataset. Now we will create a graph for this. So that no is most frequent category which maintains the balance of the dataset. Here we can see that the majority of dataset is likely has a no value and has very less frequent value of the yes. So approach for this column is that impute the missing value with the most frequent category no, which maintains the balance of the dataset. If we go for the yes, then it will create bias in our dataset. Therefore, we will choose no for this column. I will run this cell and all the values will fill, all the missing values will fill by the no. Now for the contact, we will do same for the contact also. Here we can see the contact column is also categorical and based on the dataset, cellular appears to be the most frequent category. So for this also we will use cellular which maintain the natural distribution of values. Now there is no null value found in our dataset. Now let's do feature engineering. In that, we will go for the aggregation. Aggregation is a process that helps us summarize data and extract meaningful insight. Aggregation not only reduces data dimensionality but also makes patterns and trends easier to identify. We will demonstrate this by grouping the data based on age and calculating the average balance for each age group. Here we can create age group by defining means for the age columns and labeling them appropriately. 0 to 18 for children, 19 to 35 for young adults, 36 to 50 for middle-aged adults, and 50 plus for senior citizens. The ed.cut function is used to segment the age column into these predefined means, creating a new column called age group in this data set. Let's run this code and create a new column. As the new column is created, now we aggregate the data to calculate the average balance of each age group using the following step. First, we use group by function to group data by age group, and then we will select the balance column, and it means that each group using dot mean function to calculate the mean value. Here we can see the mean value for each age group. Next step is normalization. It is a crucial pre-processing technique. Normalization ensures that numerical features are scaled to a uniform range, making them more suitable for machine learning models that rely on distance or magnitude for prediction. First, we analyze the distribution of selected numerical columns, balance, duration, and campaign using histogram for distribution with kernel density estimation. We visualize the data patterns and determine if the values are skewed or spread evenly. Here we can see that all the graphs are in skewed. Next, we use box plot to detect outliers in each column. Outlier appears on individual points beyond the whisker of the box plot. Here we can see that data points are lying beyond the whiskers of the box plot. Next, we calculate z-score to identify outlier based on the standard deviation. Value with an absolute z-score greater than 3 considered outliers. Here we can see these are the outliers based on the z-score for each column. Here we also used IQR method to detect outliers. This approach uses percentile and is more conservative, typically detecting more outliers than the z-score method. Here we can see there are more outliers than the z-score. Now, which method we will be going to use for the normalization? That IQR method generally takes more outlier because it is more conservative about values that falls outside the respected range based on the percentile, and z-score method is more sensitive to data that follows the normal distribution and can be affected by the extreme values. So here we are going to use standard scaling method for our data set. Because it has a mean of 0 and standard deviation of 1, it's suitable for data with varying range or the scale. For example, a feature with a range of 0 to 1 and another with a range of 0 to 1000 will have a comparable influence on the decision boundary after standardization. Here we have scaled our data. So next is feature construction. Feature construction allows us to derive new insights from existing data. By creating new features, we can capture additional relationships and patterns, potentially enhancing model performance. Here we have created balance to duration ratio to indicate the relative importance of balance over duration. Since some records might have duration of 0, we add a small constant to prevent division by zero. These features can help us understand how balance variance is proportion to duration, which might indicate customer engagement or behavior trends. Other we have created is day month feature. This feature represents a granular time based combination by merging the day and month columns. It allows us to analyze pattern It allows us to analyze a pattern or trend tied to specific dates, which might be helpful for time series analysis or understanding campaign effective on particular days. Let's run this cell and see. Here we get both columns, day, month and balance to duration ratio. Now, why these features are useful? First, balance to duration ratio is useful because captures are important relationship between financial and interaction time. For example, a higher ratio might signify high value customer. And second, day month combination is used because it facilitates analysis of trends on specific days or across month. It could reveal pattern like seasonality or weekdays effects. Next is discretization. Discretization transforms continuous numerical features into discrete categories, making them easier to interpret and analyze. It is particularly useful when a continuous feature does not have a straightforward relationship with the target variable. Here we had used a balance column in that we have given three ranges: low, medium and high. Here we have used float that ensures extreme values are captured without introducing any errors. Now, we had given three labels: low, medium and high. PD.cut is used to map continuous values in the balance column that define means and assign the respective labels. The described values are stored in the new column, that is balance category. Let's run this cell and here we can see balance category column. Here I had find a unique values because it will tell which columns are falling in which category of the data. Here we can see job has a 12 unique values that falls under the categorical variable. Categorical variables having a column with a limited number of unique values that represent categories or a group falls under this type. In ordinal variable, categorical variables with a natural order falls under this type is known as the ordinal variable. For example, education. In education, we have primary, secondary, and tertiary. And for numerical variable, we have a column with numeric values that can be measured or calculated. For example, age, balance, etc. Now let's move towards the descriptive statistic and visualization. In that, we are going to see redundant data. Now, what is the redundant data? Redundant data refers to duplicate or highly similar information spread across multiple features. Removing such data reduces noise and overfitting, enhancing performance model. Now, how we can identify this redundancy? By calculating the correlation coefficient between numerical features. Features with correlations above a threshold 0.7 are considered redundant. Here I had used 0.7 threshold. See, here I had used label encoder. Now, why we need to do encoding? To convert categorical values into numerical labels, making them compatible with correlation calculation and machine learning algorithm. It is more convenient for machine learning to get a perfect prediction output. So here we had done label encoding. Now the purpose for the correlation is to find the relationship between features. A high correlation, that is above 0.7, might indicate redundancy. So here we will plot the matrix. Here we can see that age group and the outcome are having a high redundant data. Now, why we have to remove this column? Because they provide overlapping information which can lead to overfitting. So here we are removing the highly correlated features. Here we can see we get P outcome and age group that are very highly correlated features, and now we drop that data. Here we can see we have dropped that columns. Thank you. From now Prasida will take over.
Hey everyone, this is Prasida. Today I'm going to describe about my part of the project which is data analysis and visualization part, which is part 2. We have taken the data set, which is bank marketing data set. We now let us get to know about the data. So to initially get to know about the data, I have uploaded my data set and then import the necessary packages in Python, and then read the data set. So once the data set information is captured here like this, so we have different attributes to this data, which is age, job, marital status, or education, default, so and so. And we have captured all the information about the data set in this form. Now we have tried to print the first 5 rows of the data, and it looks like this. Now coming to checking for the missing values in the data, we see that in the columns of age, default value, and contact value, we have lot of missing values, almost more than 1000 missing values. So let us try to understand or try to handle that missing value, right? So this is the descriptive statistics that are involved. So here, if you understand the table, we have count, unique, top, frequency, mean, standard deviation, minimum, and the quartiles and the maximum values. And we also got the interpretation for the specific columns, for each of the column, what is the interpretation. And then coming to handling the missing values that we have got, primarily with age, default value, and contact value, we have filled the age with the median value of the entire data. Similarly, a default is a categorical data, and we have tried to fill with mode. Similarly, contact, we don't know because contact is a unique value that each person has. So for the missing values, we just replace that with unknown. So after handling the missing values, if we check to see, we have seen that there are 0 missing values for all the columns. So data is handled properly. So to test whether these changes will affect, how they are going to affect our data, we try to plot a figure, which is the distribution after imputation, and the figure says that the age distribution appears to be right skewed, which is concentrated among the 20 to 60 years, right? This is right skewed and it is concentrated among 20 to 60 years, and it is going to handle the missing values properly. The label after suggests that this plot shows the age distribution after missing values have been addressed, so there is a smooth appearance. So this will say that there is no noticeable discontinuities and anomalies in the data. Now trying to address the sub part of this project, which is identifying the categorical, ordinal, and numerical values. So what are categorical values? They represent the distinct categories or labels that don't have the inherent order. So we try to identify the categorical values, which is job, and try to plot what is the trends in this values. In job value, we have different categories like this, and we can see that most common job categories are there, least common job categories, comparison of deposit subscription. So these are the common categories that are being addressed in the job category. Coming to marital status, which is married, single, or divorced, we can see how many people are divorced and they have deposited, how many people are married, how many people are single, and the percentage or proportion or ratio of the deposit values. So we can see that there is a dominant marital status in so there are so many people who are married, dominant married people, who gave the output. And then we had default category, and we can see that proportion of default status, which is minority status and majority status. Majority status of majority of the clients do not have the credit in default, and the minority have, a small percentage of people have the credit in default. Coming to housing, whether the client has a housing loan, yes or no type. So we have seen, we have created a bar plot or account plot which is stating how many people have taken housing loan and they have deposited, and how many people have not taken and they have deposited, in that way. And coming to loan, whether the client has a personal loan or not, we have again created a bar plot indicating the status of this. Similarly, contact communication, whether it is telephone contact or cellular contact, or the one that we have replaced with the missing values which is unknown, and we have created a bar plot for this. Similarly, for the outcome values, we also created how many people, or the outcome of the people of previous marketing campaign. So in that way we have created a bar plot. For everything we have also given the figure interpretation. Now coming to the second part, which is ordinal values or ordinal variables, which is having an order, specific order, which is, for example, you take education. Here we have primary education, secondary education, tertiary education, right? So how many people are having the primary education, tertiary education, secondary education and primary education with the deposit as the criteria? We can see that from this, deposit is the output variable for us in this problem. And then the month, Jan, Feb, March to December, and we can see the trends in the scatter plot that we can see here. How many people have taken? It is grouped by the month and the deposit. Deposit can have yes or no type. Deposit subscription trends over months. And then we have the numerical values. For example, the quantitative or continuous variables are all the numerical values. For example, the age of the client is distributed in this box plot. So here both yes and no categories have similar median ages. As you can see, almost they are similar. And then the yes category has slightly wider interquartile range. So outliers are present in both the groups. So this is what we can see the trends in this data by age. Similarly, balance over years, which is like average yearly balance, is also denoted by the box plot. And we can see that the balance distribution among the clients based on the deposit status, which is yes or no category, shows similar range of median balances. Now coming to duration, which is the last contact in seconds, we can see a scatter plot which is denoting the relationship between the contact and the duration. Contact duration and the balance. This plot shows that if you see, there is a lot of concentration of both the subscribers and non-subscribers at a shorter distances. Now coming to campaign, the number of contacts that are performed during this campaign for the client. So we can see that there is a relationship that we are plotting around with average balance and number of contacts. So the relationship between the number of campaign contacts and average balance of the clients, and each point represents the client with a color indicating whether they have subscribed to the deposit or not. So here red represents yes and blue represents no, the subscribers and the non-subscribers. So as the number of contacts increase, as you can see, the average balance is more varied. So as the contact frequency raises, so this suggests that beyond a certain point, increased contact attempts might not significantly boost subscribers. The next part is P days, which is number of days the client was last contacted, and we can see the point plot here. Then coming to the correlation between the numerical values, as you can see that the correlation matrix is provided here based on the numerical values, which is previous, campaign, P days, duration and balance. Now coming to the part 2, which is providing measures of centrality and distribution with visualizations. So we have numerical values that are to be analyzed. We have already analyzed these, and we have the statistical summaries of each numerical value. By taking this columns with the statistical summary, we can get it like this. For age, what is the mean, median, mode, standard deviation, variance, skewness, kurtosis, and similarly for other numerical values. Now coming to the visualizations of each of these columns with the statistical summary table, we can see that the blocks plot is given for the distribution and histogram is given for the density distribution. For the age distribution, which is showing the majority of clients that lie in terms of age. So here the box plot is denoting that the median age is around 39, where the most of the clients are falling in between, and there are some outliers that are there, wherein the age is beyond 70 to 90. These are considered to be the outliers for us. Histogram with KDE is like basically the histogram reveals a concentration of clients. Here also it reveals the concentration of clients are between the age group of 30 to 50, and it is rightly skewed, which means that most of the clients are in their 30s and 40s. Now coming to the balance, the measure of centrality is the balance has a wide range and high skewness due to outliers. We plotted the Weiland plot and log scale histogram. This Weiland plot is suggesting us that most of the clients have lower balances with a long tail extending to higher balances. Right, and then coming to the density is concentrated at the lower end, as you can see here, indicating a larger number of clients with relatively lower balances. Now if you can see the log scaled plot over here, we can say that the skewness, by using this log scale, the histogram is extremely right skewed. So you can make the interpretation or distribution more interpretable. Majority of the clients have lower balances even in the log scale histogram, with fewer clients holding significantly higher balances. Now coming to the duration, which is call duration trends over a long tail, meaning that some clients had significantly longer calls. For that also we have plotted box plot for getting out the outliers, and histogram for the general distribution trend. Here the outliers reveals that number of outliers were significantly longer calls, because we got lot of outliers over here. And the histogram distribution says that the concentration of calls with shorter durations with a steep decline is constantly increasing. So a longer tail indicating that most of the calls are short, some extend much longer. So now coming to the campaign, which is the number of contacts made during the campaign. Most clients had a few contacts. If you can see the bar plot and the blocks plot for this observation. Now coming to P days, we have seen that the number of days since the client was last contacted. Many entries have value -1 indicating no prior contact. Now coming to the number of contacts performed in previous campaigns. This is highly skewed and most contacts were contacted few times, like this. Now coming to the part 3, which is diagnosing like for the correlation between the variables and determine the independent and dependent variables. So first, step 1, we have to calculate the correlation matrix. So here we are using the Pearson correlation coefficient, where it ranges from -1 to +1. -1 is a strong negative correlation and +1 is a strong positive correlation. A correlation which is close to 0 indicates that there is no weak or strong relationship. So in terms of that, if you can see, we have pointed out the correlation matrix and we have got the entire correlation matrix in this way. And the interpretation of this matrix says that the balance part, the balance column is showing no correlation because it is all the values are almost close to 0. It is not close to either -1 or +1, and so it is not indicating any strong correlation between the with the other variables. In a similar way, if you can even see the duration, it has a slight positive correlation with the balance, which is like 0.02, indicating that longer calls might have minimal association with the higher balances. So similarly, a campaign, it also provides a small mild positive correlation, very mild, but it is not having a very strong correlations. So suggesting that more contacts associated could be associated with more past client interactions, if you can see the trends. Similarly, P days is showing a moderate positive correlation, which is 0.45. This is only the moderate positive correlation that we have. And coming to the previous previous column, there is a strong correlation with P days. You can see, uh, which is also reflecting the relationship between prior contacts and the time since last contact. Now coming to identifying the strong and weak correlations, we have identified a strong correlation, but we have not got much of a strong correlations in this plot, but there is moderate to weak correlations that are being identified with this. So we got a very mild positive correlation with the campaign and the duration. Now coming to the next aspect in this, which is determining the independent and dependent variables. So in context of the bank marketing data set, the dependent variable is like typically when what are you trying to predict through. So you are trying to predict or classify. In this case, the deposit column is basically indicating whether the client has subscribed to the bank term deposit or not, based on certain conditions. So that certain conditions or that certain parameters are only nothing but our independent variables, and the deposit, which is the client who is who has subscribed to the bank term deposit or who has not subscribed to the bank term deposit, is going to be our dependent variable. So here the deposit column is going to be the dependent variable, and all other parameters which are depending on this is like the independent variables. Here in the independent variables are independent of each other, they don't depend on each other. Only the deposit column is depending on all these independent variables. So here we have numerical variables, categorical variables, all these put together will predict whether the client has subscribed to a deposit or not. So that is what is the determination of independent and dependent variables in our case. So now if you want to visualize the relationship between the independent variable and independent variable, here we have each column representing a relationship with the deposit column. So which is the dependent variable. So suppose for example we want to plot a numerical, all the numerical variables versus deposit, for example, and we got a plot like this. right? So here we have got, suppose we have taken balance distribution by deposit, so wherein our x parameter is balance and the y parameter is like x parameter is deposit, which is the dependent variable, and the y parameter is balance. So here we can say that the overall distribution where median is the median balance for non subscribers is noticeably higher than for the yes subscribers. So and similarly, specific observations for non subscribers, majority are of non-subscribers are having between 0 to 20,000 euros. So subscribers are balances between 0 to 20,000 again, and which is similar to non-subscribers, and there are few outliers. So similarly, we also try to plot count plot for job, education, marital status with respect to deposit, which are the categorical values. So categorical values here like this, we have plotted different values and yes or no for them. And we also try to plot visualizing the correlation between the features for numerical variables with respect to deposit value. So you can see that we have got for different values, which is age, balance, duration, campaign, previous, for all the respective values. And then the step 5 is identifying the redundant features, like we are looking for highly correlated independent values. If the duration and campaign are highly correlated, you might want to keep only one of them for the modeling, so that redundancy is reduced. So similarly, like p days and previous are correlated, we might consider only one feature selection for that. So now we are checking for multi-collinearity using VIF, which is the identification of redundant values, if any, using this method called variance inflation factor. So we are computing the variance inflation factor for all the values like this, and if the variance inflation factor is above 5 to 10, it suggests that there is a significant multicollinearity. So meaning that the highly that the variable which is highly correlated like with the others in the model. So if we don't have, as you can see, that values are not beyond 5 here, or 5 to 10, so we don't have a good score of VIF, which means that we don't have high multicollinearity with the others in the model. So that is what we have interpreted from this code. In context to predictive modeling problem, the dependent variable is also known as target variable, as we have already discussed before. So here deposit is the dependent variable. Why it is the dependent is the data set marketing represents the deposit, and we have said it is a type of binary categorical variable which is having two possible outcomes: yes subscribed or no not subscribed. So this is a typical classification problem. We have identified from this analysis that this is a typical classification problem, and it is a supervised learning problem, supervised classification problem. This variable is typically dependent on the target variable, and the goal is to classify the clients into one of these. So others are independent variables because they are not, suppose age is not dependent on job is not dependent on marital status or something like that, so it is independent of each other. So these independent values together constitute or together build to help the deposit column. So that is why they are the individual independent variables. So we have identified the dependent variable as deposit, and all the independent variables except deposit variable is going to be the independent values. So now we are performing the exploratory data analysis in the combination with visualization techniques to discover some patterns in data. So here we have got the generalized overview of the data, which is data shape and types. We've got the data shape and types. We have already been doing this before also, but again we are doing this for the purpose of clear understanding. We have done the univariate analysis where the single variable is involved, which is categorical features are distribution of categories, different categories. So categorical features like job, marital status, or education, default housing, whether they are taking the housing loan, personal loan, what is their contact information, what is their month outcome. So these are the univariate analysis, and for each of these thing we have again plotted with the visualizations, count of the jobs people, job categories, what is the count of job categories, what is the count of marital status, education, which is territory, secondary, unknown, default, yes or no, housing loan, whether they have taken housing or not, like yes or no, distribution of the loans, distribution of the contacts, distribution of the months. Like this we have taken the individual analysis, single univariate analysis, single variations, and then again we have taken the numerical features where the distribution of values are being taken care of. So we have taken, previously we have taken the categorical variables, we are taking the numerical variables, and we are trying to plot the figures for all of them, the distribution of age, distribution of balance, what is the distribution of this duration or campaign or p days, like this. Now coming to the bivariate analysis where we are trying to identify the relationship between two variables. So similar to the previous code, we have already tried to do the relationship between the two variables in this form by taking the relationship of the numerical values with the different parameters, deposits. So here we have taken the considerations like age, balance, duration, campaign, p days, previous with the deposit. The hue is the deposit here, and tried to plot the values. And then numerical versus categorical variables, we have taken the relationship, what is the relationship between the categorical target with the numerical variables by using the parameter deposit. And we tried to plot the box plot for everything to identify the outliers for each of the understanding. Then we have taken the next parameter is multivariate analysis, which is the correlation heat map for all the values for all the attributes. So here we have taken the correlation analysis which we have already done before, and we have identified the correlation matrix. And now coming to the insights and feature understanding, here we have understood the feature importance for each of the features. We have understood the feature importance, the what is the imbalanced data, what are the outliers, how is the skewness, what is the skewed distributions, which we have also understood the potential multicollinearity in the data. I think these insights and feature understanding will help us to know more about the data in clear, in understandable way, so that we can proceed up with the next part of our project, which is trying to identify the supervised or unsupervised learning, and through that predicting the values. This is what is the clear data analysis and visualization explanation of my part. Thank you so much.
Hi, my name is Sindhu. I'm going to explain about the third step of the project, which focuses on predicting whether a customer will subscribe to a term deposit based on various attributes such as age, balance, job type, with the help of machine learning techniques. As we know, supervised learning involves training a model on a labeled dataset where the features of the input data are paired with known output labels, that is, the target. And unsupervised learning involves training a model on an unlabeled dataset to know about hidden patterns, structures in the data. As our dataset is labeled, and since the target variable is binary, that is, the deposit is the target variable, which has values either yes or no. This is a classification problem, and we utilize supervised learning techniques to build predictive models. As we have identified why supervised learning fits our dataset, let us now identify the dependent and independent variables. Dependent variable is the target, or in our case, it is the deposit. This is the outcome variable which is to be predicted. In our case, the dependent variable is deposit and has a binary value either yes or no. It indicates whether a customer subscribed to a term deposit or not. And the rest of the variables are potential predictors of the deposit outcome. Hence, they are called the independent variables. They can be classified into numerical features such as age, balance, duration, etc., and categorical features such as job, marital status, education, etc., and temporal features such as day. For our problem statement, that is for predicting whether a customer will subscribe to a term deposit, we built three popularly used classification algorithm models, that is the logistic regression, decision tree classifier, and the random forest model. First, let me explain about the logistic regression model. Firstly, I have imported all the necessary packages. The next step, I have read the CSV file from the system. Here, I have printed the first 5 rows of our dataset. Next, I have identified the categorical variables. After identifying the categorical variables, I have converted them to numerical representation to make our machine learning models effectively understand the categorical variables. For example, the deposit column is a categorical variable. Hence, through one-hot encoding, we convert it to deposit yes column, having either true or false as values. I have assigned deposit yes as target column and the rest of the columns as predictor columns. Next, I have handled all the missing values. As you can see here, before handling the missing values of age are 1339 and later on they have reduced to 0 after handling. I have replaced all the null values with the median and the mode wherever necessary. Next, I have splitted the entire dataset into training and testing dataset. 30% of the entire dataset is set aside as testing dataset with a random state of 42. Here, I have initialized the logistic regression model and we have predicted using the test dataset. Here comes the evaluation part. I have used accuracy, precision, recall, and F1 score as evaluation metrics. Here we can observe that is 90% of accuracy for logistic regression model. Next, let me walk you through the second classification algorithm which we used, that is the decision tree algorithm. Firstly, I have imported the decision tree classifier package. Next, I have initialized the decision tree classifier model and I have trained with the training data set. Here I have predicted using the testing data set. Now I have evaluated the model's performance by taking accuracy, precision, recall, and F1 score. Here we can see the accuracy of decision tree model is 87%. Next, let us go to the third classification algorithm, that is the random forest algorithm. Firstly, I have imported the random forest classifier, and in the same process, I have initialized this model, trained with the help of training dataset, and made predictions. Now, I have evaluated the random forest classifier with the help of the metrics accuracy, precision, recall, and F1 score, as well as confusion metrics. As we can see, the accuracy is 90%. Now, to understand which classification algorithm is better among the three, we are using one of the frequently used metric known as ROC-AUC metric. The ROC-AUC metric, which stands for Receiver Operating Characteristic Area Under the Curve, is a crucial evaluation tool in classification algorithms as it provides a single comprehensive measure of a model's ability to distinguish between positive and negative classes across all possible classification thresholds. The higher AUC value indicates better model performance. Now, we are comparing the ROC AUC metric for each of the classification algorithm. Firstly, we have initialized the models. Next, we are storing the ROC metrics in a list. For plotting the figures, we have given 10 by 8 size. Next, we have plotted the ROC AUC curve here. As we can see, these are the curves of ROC AUC for each of the model. We can see that this plot depicts the ROC curves for each of the classification models. And here are the ROC AUC values. The higher the value, the better is the model's performance. As we can see and compare, the random forest algorithm has the highest value of ROC AUC metric. Now we will compare other evaluation metrics. Here is a table wherein three of the algorithms are compared with the following metrics: accuracy, precision, recall, and F1 score. Among the three classification algorithms, random forest algorithm holds the highest accuracy, that is 90%, and having the precision of 66%. Hence, random forest algorithm is best suited classification algorithm to predict the number of people going for term deposits. Thank you.